Hello students, how are you all? Welcome to the fifth part. Yes, fifth part of the chapter Refraction of Light. And in this fifth part, mainly we'll see that we'll pass a ray of light through a glass prism. Okay. And we'll change the angle of incidence. And if we change the angle of incidence, how the ray will refract. Okay, all this we'll discuss. And we'll see some required formula also of prism, and plus we will apply those formula in numericals. Okay, so this session is going to be a very important one for your exam. Understood? And in the first part of the chapter refraction, those first four parts, we discussed so many other things related to refraction. If you have missed those videos, the link of those first four parts are there in the description box. You can check that. Okay, so let us start this session where we are going to discuss, as I told you, that glass prism, and we'll send the ray through that glass prism. Okay, see this. First of all, this is the prism. Okay. Here I am going to tell you something, some terms I will tell you. You have to store those terms here. Yeah, here. See how? First of all, I am sending a ray. Okay. This is normal. Then this is angle of incidence. Angle of incidence. Okay. Now, this ray is going. Here is the normal again, and the ray is going like this. Got it? This is an angle, this is another angle. Okay, this angle is called angle of incidence, this is called angle of emergent. Okay, this is angle of refraction. Okay, this is another angle of refraction. R1 and R2 are angles of refraction, we can say. And this is angle of incident and angle of emergent. Okay. But I will change here. I will not denote it as E. I will denote it as I2. Okay. And this is as I1. Why? So that you can easily remember the formula which I am going to tell you now. Okay. So I1 is the angle of incident and I2 is the angle of emergent. Okay. Now see, the ray was going like this. No, the ray was going like this, straight. But because of this prism, the ray is going this way now. No, the ray was going straight. The ray was going straight, but because of this prism, now the ray is going this way. Okay. And same here. First, the ray was going this way, but because of this prism, the ray is bent. So, if I produce it, so here I am getting an angle. See, I am getting an angle here. Okay, because the ray was going this way and now the ray is going this way. So I am getting an angle here. This is called angular deviation. Okay, and we'll denote this angular deviation by delta. Okay, this symbol is called delta. Delta is the angular deviation. Angular deviation means first it was going this way, but because of this prism, now it is going this way. So it's made an angle. Initial direction, this is final direction. With this they are making an angle of deviation. Okay. Now, and this is called angle of prism or refracting angle of prism. Okay, it has got two names, angle of prism or refracting angle of prism. Okay. And this angle of prism equal to always R1 plus R2. Yes, R1 plus R2 means A. Okay. And deviation equal to I1 plus I2 minus R1 plus R2. Okay, this is another equation. Angle of incidence plus angle of emergent minus this R1 and R2. Okay, so we can also say that angle of deviation equal to I1 plus I2 minus R1 plus R2 means A. So that is A. So this is another equation. So I told you 3 equations. You have to store it. Yes. Now this is the prism, and now we are going to change this angle of incidence. Okay. We'll change the angle of incidence now. We'll increase it. And we'll see how this angle of deviation behaves. You understood my question? I told I will increase the angle of incidence now. I will increase the angle of incidence and I will see how this angle of deviation changes. Okay, for that I will tell you a graph. See, this is the graph. This is angle of incidence, okay, I1, and this is deviation, delta. Okay, so see what I'm saying. If you increase angle of incidence, you will see that angle of deviation is decreasing. Yes, if you increase angle of incidence, then angle of deviation decreases. But after a fixed value, it starts increasing. You understood what I said? If angle of incidence increases, then first angle of deviation will decrease, then again it will increase. Okay, let me show you the graph. This is the graph. See, if you increase the angle of incidence, first the angle of deviation will decrease, then it will come to a minimum value, okay, the least value, then again it will increase. Understood? Now this minimum value, we call it minimum deviation. Minimum deviation, and we denote it as delta mean. Okay, delta mean. So as I told you that if you increase angle of incidence, you will see that angle of deviation decreases first and then again it increases. So the lowest value, the least value which we got, we call it minimum deviation. Okay, that is delta mean. And one more information for you, when the minimum deviation takes place, I mean here delta mean, then we notice that angle of incidence and angle of emergent becomes equal. Yes, see how this at minimum deviation, angle of incidence equal to angle of emergent. Angle of incidence and angle of emergent becomes equal. So from this equation I can write delta mean equal to, or I will write here, see, delta mean equal to I1 and I2 both are equal. I1 and I2 both are equal, so I am taking it I. Okay, I1 and I2 both are equal, so I am taking as I, small I. Okay, so I plus I minus A. So delta mean equal to 2I minus A. This is another equation. You have to store it in your brain. Delta mean equal to 2I minus A. What is I? I is angle of incidence or angle of emergent, because at minimum deviation, angle of incident and angle of emergent both are equal. And A is refracting angle of a prism. This one. Okay. So these are the formula and the relation between angle of deviation and the angle of incidence. Okay, now you saw how the angle of deviation depends on angle of incidence. Okay, now we'll do some numericals based on this formula. Let's start. First numerical: a ray of light incident at an angle 48 degree. Okay, a ray of light incident means angle of incidence equal to 48 degree. Okay, on a prism of refracting angle 60 degree. The prism's refracting angle, yes, capital A equal to 60 degree, and suffers minimum deviation. It suffers minimum deviation. Okay, delta mean. Find the angle of deviation. Find the angle of minimum deviation. We have to find the angle of minimum deviation. We know the formula. Delta mean equal to 2i minus a. What is 2i? I is 48. 48 minus a, 60. So 96 minus 60, that is 36 degree. Simple? Yes, just you have to remember the formula. Let's move to our next numerical. Let me take out the next numerical. Yes, the next numerical. What should be the angle of incidence? Here you have to find the angle of incidence. Means I1 you have to find angle of incidence of a ray of light which suffers minimum deviation. Again minimum deviation. Minimum deviation of 36 degree. Here minimum deviation is given. Minimum deviation is 36 degree. Okay, through an equilateral prism. Here equilateral prism is there. This is the prism. Equilateral prism. This indicates that all the angles are 60 degree. I mean angle of refracting means angle of prism is 60 degree. Okay. Here the angle of prism is not given directly. Here they are saying that the prism is equilateral prism means all the angles are 60 degree. So angle of prism is 60 degree. Now again we'll use the same formula. 2i minus a. What is delta mean? Delta mean is 36 degree equal to 2i. What is 2i? We do not know. Minus a is 60 degree. Okay. So 36 plus 60 equal to 2i. That is 96 equal to 2i. So I equal to 96 by 2. That is 48 degree equal to I. Yes. So angle of incidence is 48 degree. Okay. So what we discussed? We discussed that when a ray is passing through a glass prism, then by changing the angle of incidence, we can change the angular deviation. Angular deviation, you remember? The light is going like this, but because of the prism, now the light is going like this. So the angle, yes, angular, that is called angular deviation. Okay, angular deviation. So how they depends on each other, and we also see the required formula and the related numericals to that related formula. Okay. So meet you in the next video. Till then, bye bye.